In Lesson 1-6, you'll learn to identify and name polygons and find the perimeters of polygons. How are polygons related to toys? There are numerous types of building sets, such as connects, that connect sticks to form various shapes. Whether they are made of plastic, wood, or metal, the sticks represent line segments. When the segments are connected, they form angles. The sticks are connected to form closed figures that in turn are connected to make a model of a real-world object. A polygon is a closed figure formed by a finite number of coplanar segments such that the sides that have a common endpoint are non-collinear and each side intersects exactly two other sides but only at their endpoints. A polygon is named by the letters of its vertices written in consecutive order. So this triangle could be named as ABC, or it could be ACB or CAB. So the order where you start doesn't matter, but once you've committed, so if they do WX, then they have to continue YZ. But you could have started with X and gone WZY. It doesn't matter. This is not a polygon because it is not a closed figure. This is not a polygon because it is not made of line segments. And this is not a polygon because it's two polygons touching, but it's not one polygon because it crosses over. Polygons can be concave or convex. Suppose the line containing each side is drawn. If any of the lines containing any point in the interior of the polygon, then it is concave. So this guy goes through the interior. Otherwise, it is convex. Okay, so I have a little stickman illustration. If it's concave, my little caveman here can get inside the cave, and if it's raining, he will be dry. If it's convex, he's going to get rained on, so he's going to be upset or vexed, not happy. You're already familiar with many polygon names, such as triangle, square, and rectangle from kindergarten. In general, polygons can be classified by the number of sides they have. A polygon with n sides is an n-gon. The table lists common names for various categories of a polygon. The term polygon is derived from a Greek word meaning many, poly, angles. Since hexa means 6, you would think hexagon means 6 angles, and you would be correct. Every polygon has the same number of angles as it does sides. A convex polygon in which all the sides are congruent and all the angles are congruent is called a regular polygon. Octagon PQRSTUVW below is a regular octagon. Name the polygon by its number of sides, then classify it as convex or concave, regular, irregular. Okay, so we have 3 answers to one question. So by sides it has 1, 2, 3, 4, and they've marked them with different marks. They're all different, so it is just a quadrilateral. Extend the lines that are the sides. There are not going to be any lines going through the interior, so it is convex. And the sides are all different lengths, so it is not regular. The opposite of regular is irregular. 3 parts, but they went pretty quick. Let's look at another one. Okay, name the polygon by its number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. Looking at the table is a nonagon. Then the sides, I do get some that go through the interior, so it's going to be concave. And the sides are not all the same length, and the angles are definitely not the same, so it is definitely irregular. So again, 3 parts to one question, but they went pretty quickly. Perimeter is just distance around a polygon. The perimeter P of a polygon is the sum of the lengths of the sides of the polygon, and they show examples of a triangle, square, and rectangle. A masonry company is contracted to lay 3 layers of a decorative brick along the foundation for a new house with the given dimensions above. Find the perimeter of the foundation and determine how many bricks the company will need to complete the job. Assume that one brick is 8 inches long. So all we need to do is pick a spot and just add. So 36 plus 24, 12, 36, 40, 38, and another 30. And I mark my spot so I could remember where I started. And when we add, we get 216 feet for the perimeter. But then they ask how many bricks we're going to need. Well, we need to change feet to inches. 1 foot is 12 inches. And then they said each brick, 1 brick, is 8 inches. So now I've got the number of bricks in 1 layer, because the feet would cancel out, the inches would cancel out. So 216 times 12, because it's in the numerator, divided by 8, it's in the denominator. Type it in the calculator, I get 324 bricks in 1 layer. But we needed 3 layers, so we need to take that times 3. So 3 times 4 is 12, carry the 1, 2 times 3 is 6, plus 1 is 7, 3 times 3 is 9. We're going to need 972 bricks for all 3 layers. The builder realizes that he somehow or another, he accidentally halved the size of the foundation in part A. How will this affect the perimeter of the house and the number of bricks the masonry company needs? Well, if you only counted half as much, the perimeter will double. We'd have to take the number of bricks times 2 as well. So he'd need twice as many bricks, or 1,944. Find the perimeter of pentagon ABC with the given vertices. Okay, so what was 5 separate problems is all going to be done in one, and then we're going to add it together. Let's get the easy ones done first. ED is going to be 1, 2, 3, 4, 5. DC, 1, 2, 3, 4, 5, 6. Okay, so to do BC, we have to use our distance formula, and I went ahead and counted squares because it's graph for us. So it's going to be square root of 1 squared plus 4 squared. So 1 plus 16 is 17, which should be approximately 4.12 using my calculator rounded to the nearest hundredth. Okay, counting squares for the legs of the right triangle that makes AB as its hypotenuse. They're both 4. So we'd have 4 squared plus 4 squared, square root of that. 16 plus 16 is 32. And I think we're just getting it as a decimal today. That's about 5.66 rounded to the nearest hundredth. It looks like the legs of the right triangle that have AE as the hypotenuse are both 3. So we need the square root of 3 squared plus 3 squared. So 9 plus 9 is 18, which is, square root of 18 is about 4 24/100ths. Okay, adding up the numbers I had, I get 25 200ths. So we could say it's about 25 units for the perimeter. Okay, that looked like straight out geometrical stuff. On our last example, we're going to use a little algebra. The width of a rectangle is 5 less than twice its length. The perimeter is 80 centimeters. Find the length of each side. Whenever you can draw a picture, you should draw a picture. So they let L be the length. So the width is 5 less than twice. So twice means times 2. So to do 5 less than twice the length, it's 2L minus 5. And we know in a rectangle that opposite sides are congruent. So the whole perimeter needs to be 80. So now I just have a little algebra to finish it up. Combine my like terms. 1L plus 2L is 3L, plus another is 4, plus 2 more would be 6. And then we had, that was in minus 5. So negative 5 plus negative 5, or minus 5, would be negative 10. And add 10 to both sides. Divide by 6. And we get L is 15. Okay, it says find the length of each side, so that's one of them. So to get our width, the expression was 2L minus 5, so I just need to substitute in that. 2 times 15 minus 5 is 30 minus 5, which is 25. And once again, they did give us units. Okay, so that's centimeters. And we're done. A polygon is a closed figure made of line segments. The perimeter of a polygon is the sum of the lengths of its sides.